All right, everybody. So I understand that factoring could be a little bit more of a problem. And it's not a whole lot of an issue if you've been practicing. So that's kind of like the way it goes. So I want to do another video about all factoring techniques. Now, all factoring means there's plenty of more other techniques out there. I'm just going to give you kind of like the gist of a lot of them, but I'm not going to go through every single one of them because there's a lot here. So let's look at maybe a couple of these here. So if we kind of look at these here, let's go down to this one right here first, because let's kind of do a little introduction first here. So remember, when you are factoring something like x squared minus 9, this is what we call a difference or difference of squares. Now, you probably heard this term, it's called squares. The reason this is squares because think of this as like a 2. This is a 2, right? What else can I do to this 9? Well, can I go 3 squared? Well, that is the same thing as this. So we're going to say that this is a difference of squares because once it's a difference and this is a square and this is a square. When I say a square, it's kind of like, this, it's like saying this times this, which gives you x squared. That's kind of what we talk about this. So when we say a difference of squares or a sum of squares, we can kind of go this way, but a difference of squares says, hey, if I have this difference of squares, well, one, I can use two parentheses and I can put x here, because if I put x there, x squared, or x there, I have x squared if you FOIL. Remember, in recent videos or other videos, I said that you have to FOIL to check, or box method, or how you want to approach this. But you have this FOIL access to do that, to check. But also, this is factoring. This is factoring going this way. So let's kind of continue this. So if I have 3 squared, well, that 3 and that 3 there go there. And then I have to worry about this. This, remember, does not have a middle part. So remember back in the quadratic equation, well, or expression, this is really an expression because equations have equal signs. This is just an expressions. This is without the equal sign. That's why it's called an expression rather than an equation. An equation would have an equal sign. So this expression, the middle term is gone. This is your A, this is your C, but there's no B. So how do you get no B from here? Well, you have to understand that if I put a positive and a minus and I FOIL this, I should get that. Now, that is the factored form. Now, if it's said to solve, I hope you know what to do. I'm not gonna go into that. But there's your factor. That's called a difference of squares. Now let's move up here to this x to the fourth minus 1. Now, x to the fourth minus 1 is really not that bad. It's almost like the difference of squares. Think of this as like a fourth of squares, or a fourth of a fourth. I don't know how you want to say that, but there's really no word on that. It's just a polynomial, but we want to factor this polynomial. So here's what you should recognize. One, there's a 4 right there. There's a 1. So here's what you could do. You can say, okay, this is x to the fourth minus 1 to the fourth. Do you see what I did? Because this is 1 times 1 times 1 times 1, which is 1. So I'm just going to dress it up like this. So this is going to be like, hey, I'm going to break this down like this with two parentheses. Well, what I'm going to put here, if this is x to the fourth, is it possible that I can do that? Do you know why I did that? The reason I did this is because this is really that. That is really that. If you think about properties of exponents. Properties of exponents says if I take this and square it and multiply the exponents, I get 4. This is what I'm doing here. I'm taking this and making 1 and 2 of them there. Now I have a 1. And so I'm going to go 1 and 1. Okay, remember how this right here has no middle value? I'm just going to go ahead and put plus and minus. And that, if you FOIL that, should be that. The only thing that we have to be very careful about is that this right here is done. We can't factor that part anymore because you would run into I. But look at this part. Isn't this kind of like what we did down here? Isn't these two very similar? So we have to factor this a little bit more. This is a difference of squares again. Think about it. This part right here is I. We can't really do too much of that. It's complexed. But this, we can go ahead and do this and go x plus 1 minus 1. And so that is where you get the four solutions. But we have two real and we have two complex. That's where you get the 4 at. So we have two reals. The two real are right here. And then the two complex, which come here because those are pairs. So now we have that put together. Well, let's move on to another technique. This technique is something to the third power. So I'm going to rewrite this. This is x to the third, and this is 2 to the third. Is that true? You're probably going to say, yes, it is true because x to the third is that, but 2 to the third is 8. Cool. I'm going to go through here now, and I'm going to take this thing. It's called an acronym. It's called SOAP. Now, what this means, it's an acronym for something like this. So it says same, opposite, addition, parentheses, or just parentheses. Parentheses is these two things. Now, so we're going to use this technique, and you can look this up if you want. This is called a difference of cubes. So let me write this down. It's called a difference of cubes. If you want to look it up on your own, you can. I'm just going to run through it, but you can look it up if you want to know the proper procedure. But it's going to have two parentheses, but this one's going to be a little bit bigger. So I'm going to use x here. I'm going to go ahead and look at this here. I'm going to look at the same. The same sign is right there. That's the same. I'm going to use one of these. Do you see how I used one of those already? One of each of those already? And I used the S for the same. Now I'm going to come over here, and this is going to be x squared. Because if you think about it, if I multiply these, don't I get x to the third? Okay, now let's look at SOAP. Opposite sign. So this here is going to be opposite sign because of that part right there. Now you're going to look at these. You're going to take this and you're going to take this and you're going to put 2x. Then you're going to come over here. Do you see where it says addition? You're going to put an addition. And then you're going to come over here and you're going to say, okay, what is this? Well, this is going to be 2 squared. 2 squared is 4. And there you go. That's the factored form of that one. Like I said, you might want to look this up. So you might want to look this part up. It's called the difference of cubes. There is a formula for that, or maybe a helpful technique that you can kind of get, but it's this basic stuff here. I'm not going to go through that because of our time on this. I just want to make this, that you can kind of see all these different techniques. Now, what I want to do is kind of go to this last one. Now, this last one has 4 terms in it. Now, you're probably thinking, okay, what do I do? I want you to look up something. It's called grouping. Factoring by grouping. And what this means is that you're kind of grouping similar things to each other. So this is kind of what I'm trying to talk about. Do you see how you have 4 terms here? 1, 2, and 3, 4? What I'm going to do is try to group the things that I have kind of in common. Do you see what's in common there? It's a 5, right? Do you see what's in common there? You have your x's. So if this part doesn't work, you might have to rearrange things. but I made this work just because of our video here. But what I might want you to do in the future is to maybe change this around a little bit and see if it works. And this is what I'm going to show you here. So this is called factor by grouping. So there's 4 pieces here. I'm going to take this and I'm going to cut it in half. I'm going to cut this in half. And then on this side, I'm going to look at the GCFs. If you saw my other videos, this is very similar to what we were just doing with factoring regular quadratics. So here we go. We're going to factor this. So the GCF on this side is going to be x squared. Do you see that? Do you see why it's x squared? So if I pull out an x squared on this side, what's the leftovers? I'm hoping that you're going to go, oh, that's x minus 4. And you would be right. Okay, so that's x minus 4. On this side, what is your GCF on these two? 5 and 20, you're probably going to say, hey, I know that's a 5. Okay, what's left over? Well, then you have, what we have to be careful here. If we pull out a 5 here, that's that minus 4, right? If you need to check, multiply this. Take this, multiply, take this, multiply, you should get to that. Now, if you saw the other videos on this, do you see how these two are the same? Well, that's one of your factors. Those become one of your factors. Now, on this side, you see how these are going to, your GCFs? See how these are your GCFs? Well, these are going to be x squared plus 5. Technically, we are done. But you're probably thinking, can't I do anything else with this? You can if you were to solve. But we're not solving because factoring just means doing this, doing factors. To check this, you could just FOIL them back. But I just want to focus on the factoring rather than the solving on this one because this is kind of the way that you would approach this. So let's maybe try maybe one more. That's a little bit more complicated. So I have one for you. So maybe we should kind of try, I don't know, let's do, what about x to the 4th? What about 2x squared minus 15? Now you're probably looking at this one and say, oh my Lord, I don't know what to do here. Well, you have to be very cautious here. And here's what you could try to imagine doing. Maybe you can try a couple things. I see a 4th power. I see a 2nd power. And maybe you could, try something like this. Will this work? Well, let's try it. Let's just see if it works. Well, let's see. I got to go 1 times 15 is negative 15. And the negative 2 comes down here. Okay, cool. I'm off to a good start because I kind of see maybe a little bit about what to do here. If you saw my other videos, remember this is AC and this is B. If you look at this form here, oops. If you look at this form, it's that. If you saw my other videos, you should be fine with that. But if you're not, you might want to. So here we go. I see this like that. I'm going to go that, and then I'm going to think about some numbers here. Now you're probably thinking, let's see, what about, we got to make 15. So 1 and 15, 2 doesn't work, 3 times 5. I think 3 times 5 would work. So let's put 3 and 5. And let's see what the sign is here. Let's see, the sign is going to have to be, we have to make negative 2. So I think that's going to work. So let's go ahead and add this to our collection. So you're going to go x to the 4th. You're going to go ahead and plus 3x. You're going to go minus 5x. And you're going to go 15. Okay, you see how I did that? It's kind of like our old videos. Now, you have 4 pieces here. Let's go ahead and split this in half. Let's try to factor this side or look for GCFs. The GCF, if you're going to say x, you're absolutely right. So that's x. What's left over? Well, you have x to the 3rd plus 3. What's on this side? Well, I can take out a 5. Is it possible that we can take out a negative 5? Because we want to make that, well, that will be Oh, wait a second. That won't work because we can't make x to the thirds because look what will happen. What if I did that? Just kind of see what's going on. You don't have the same there. So remember how we did it back here? We don't have these to be the same. So you're probably thinking, okay, what am I going to do? Well, another thing that you could do is saying, okay, well, maybe we can take this idea and augment this a little bit. So if we can maybe take x squared minus 5, and then if we take x to the third plus 3. And you're probably thinking, how did you get those? Well, how did I get those is that, well, one is that I need to think about to the fourth power. And how do you get to the fourth power is this times this. Remember, you're just doing the FOIL to check. Okay, that makes that part. Now, how do I get this? Well, think of it this way. You have to make these kind of be the same. So what if I took and added a 2 here and changed the 2 there? As long as I do it to both sides, those will be right there. And then if I change those, I'm going to add something here, which is a 2. And then that will be there. And so there's my factors of that one. This is pushing it. I really have another way of doing this. And let me show you this real quick. I just don't want to make this video so long. Let me show you another way of doing this if you didn't catch that. If you did catch that, congratulations. But let's say that we have the same thing. So make sure I put this the same. I don't want to forget something. I'm going to make a little substitution. So just to help our brain, we can do this. What if I let u equals x? Or in this case, what if I let u equals x squared? Now you're probably thinking, why are you doing this? You're going to see why in a minute. You're going to see why. I'm just going to let this happen. Here's what I'm going to show you. What if I just went like this? U to, let's see, if u is x squared, wouldn't this be u squared? Because isn't u squared u to the technically u to the fourth? And then I'm going to make this, if that's 2 and that's already there, you have that. And then minus 15. Do you see what you can do now? You can go ahead and do your diamond, or if you want to, you can skip the diamond because you don't have to do that bonus feature here, and go u, and then you can go, let's see, what number is there? That's going to be, is that 3? Let's see, is that 3 and 5? Sure. And then what are the signs to make that? Isn't it going to be, let's see, negative and negative doesn't work. Isn't it negative and positive? There you go. Now you're probably thinking, we're not done yet. Look what you did here. What you're going to do is plug or replace what you have here. And you're going to go x squared plus 3 and x squared minus 5. Ta-da! And look at that. Isn't that so cool? So you might have to make a little substitution once in a while to help simplify this out, to make your brain think about this. All right. That is just a few techniques. I really want to introduce the SOAP to you, or the difference of cubes and the difference of squares, the grouping, and also this substitution. So I hope you really found this video helpful, and I will see you on the next one.